Information theory. Basically, there is something very fundamental here, which affects the artificial intelligence as well. Because where does the power or benefit of artificial intelligence comes from? Why AI is so strong and why AI is in demand? It's because of the information theory. In thousands years ago, for more than really 1,000 years, people were philosophers and scientists, everybody were putting the force or the really reason behind the change. They were putting on earth, wind, fire, and water. So by changing these four or any of them, things happened in this world. So that was the explanation for why things are happening in the world. Then came Newton. He introduced the idea of force. Force was not really as such known before as such as something entity which affects our movement in the world and change. Why the change? That's the question really. So force, and of course gravity was another type of force, is what Newton introduced. Until about 100, 150 years ago, or maybe 200 years ago, when the steam engines were created, and a lot of industries started using steam engine, and especially trains, scientists started thinking, what is the force, what is really, where does it come, that thing which makes so much change? And then the idea of energy came. Energy, which today we get used to it and we think it's everything is made of energy, and we know it's so easy. About 200 years ago was not so easy. I mean, it was created that, okay, the force or the thing, I should say the operator behind the change or this power is energy. Of course, thermodynamics was accordingly designed, the formula and the mathematical of that energy. And even today, a lot of students really, and a lot of people, yet they are in the mind of energy. We haven't learned the new era. The new era is called information and entropy, or American maybe entropy. About 1950s, a mathematician called Shannon, he was working in Bell Laboratories. He started thinking, what is behind this telegram? What we are sending, apart from the signal. Signal is going and coming, it's the same thing. But what goes behind it, and how things are passed. Then he came to conclusion that that's the information we are sending. Then he wrote the formula for it, and the entropy was created based on that. Nowadays, all who are familiar with quantum mechanics, that they know that everything is explained by information and entropy, more entropy than information really. So the force, if you call it, or the operator of the change, or things that make things to happen, is information and entropy, not energy, and not force, and not earth, water, or four elements. That's the norm today. And that's why we have to learn about it and to understand it better. For example, he wrote in his article, interesting, he said that There's this Rivoli. He's one of the quantum mechanic professors today. Is Italian. In his book, he writes, for example, if we needed energy as a humans, or anybody, we should have gone to Sahara and get the energy from sun and survive easily. But no, we have to eat rather than get just energy. If you go in the sun and still, you die. You have to eat. So he says, if energy was the source of change in this world, sun was enough, or energy is enough. But we see, no, it's not enough. Then he says this entropy. So that's a new explanation of what makes things change or survive or go ahead. Life goes on. He says life goes on because we have to break the symmetry, the simplicity, and waste it. In fact, in wasting the simplicity of the world. Entropy is a bit difficult thing to understand. Hopefully there is a video we'll see about it. Hopefully, I don't know, maybe I forgot to put it. Anyhow. The point is, I'll try to explain and then we'll see the video as well. Basically, the idea is simplicity. They call it symmetry. Symmetry means if, for example, when we say, in arithmetic, we say n. N can be 1, can be 2, can be any number. So that's symmetry, because n can be any number. That's symmetry. But when you say n equals to 1, you made it 1. You break it. It can't be 2, because now it's 1. So that's the terminology. We have to learn with this sort of terminology. So when you have this symmetry, which we can make it in 1 or 2 or any number, that's good. You can select any number. But when you make it 1, you can't move. It's fixed. It's dead. So when you make it fixed, it's dead. And when you are open to change, you are open. That's good. That's life. That's a good point about it. So that's basically is there. The idea of how we can translate this, the way our mind works, into computer. Simple system, well, make it as simple as possible. So building blocks of how our mind works. Altogether, in the world, we have two different things. There are substance and there are attributes. I mean, this is what we learn in logics from Aristotle, time of Aristotle. He mentioned that whatever there is in the world, we have something as a base and something that makes it different with others. The base is the same for everything, but you can't. But by putting the attribute, it becomes so. When you say table, for example, a table is made of wood. So even the wood is made of carbon, and carbon is made of quarks. So in today's science, as much we know, the base of everything is quarks, for example. It was atoms before, but it was something basic at the beginning. But what makes a table different from a door, from a tree, is the form, the shape of it, the attributes, the way it's done. So that's the idea. How a computer knows these differences and how we can call it what it is. So a thing and attributes are two connected to each other. You can't have attribute without a thing, and you can't have a thing without an attribute. They are two together makes something we can say it, because a thing without attribute becomes a thing of everything. So when it's everything, you can't say So what? What it is? It's the same. It's like existence. The idea, the concept of existence is exist. Okay, everybody exists. Everything is there. So what? We can't really talk much about it. And if you have attribute only and nothing real, it becomes we call it today this virtual. Virtual is not in real world, and we are talking about real world. In real world, we have matter. We have something which has to be physically there and also has physical properties. So we have properties and we have matter, if you want to put it a different word. Different words they use for it, so it doesn't matter, but maybe simple words are property, matter and property. There is another point is that when you say property, when you say attributes, these are no order in it. I mean, there is nothing, no difference between this. What is not what is more important than the other. For example, in our culture, I don't know, it's Iran, but maybe also in Arabic. But anyhow, we have this says that when the 9 comes, we have number 2, we have number 3. That's not true, because when we have 9, is only in certain things we have. When we have 9 apples, okay, we have 2 apples in it. Yes, we know, but as the abstract, 9 is different from number 1 and number 2. They are equal. For example, when you want to dial a number to get my home number, you can't dial 99999 because it's in it 1 and there is in it 2 and there is in it 5. It has to. It can't find the person. 999 is totally different from 9123. Totally different. Doesn't matter that 9 be there or not to be there at the beginning or at the end. Yes, when we are talking about 1,000, 9,000 is more than 100. We know that. We know that we have put that order. That's important. But the number itself has no order. Nothing more or less. When it comes to a password, doesn't matter. You put A at the beginning or you put Z at the beginning. Doesn't matter. It's a password. So it's letter by letter. Doesn't matter. There's no order. And the same thing is in the word. I mean, when it comes to attributes, as a body, as a computer, when it gets the information from the word, it doesn't matter what it is. So the importance comes by the program. The importance comes what we say, what is more important and what is less important. And that's what we are talking about. So the minimum thing which is there in computer in this book is called datagram. But this is not a general name. I mean, datagram is used by others by different meaning, really. But datagram is a good word by itself. Okay, this book has used it, so we use it. It's the minimum amount of data for the 1 pixel, because this book is basically talking about display, because most of the knowledge we have is really visual. But what is said here, although it's mainly for visual, explained for visual, but it can be for anything. So any sense, any sensation. By the way, how many senses we have? The normal answer
4.
is 4 or 5. No, 5. We have vision, hearing, touch, taste, and smell. But physically, it's much more. It's about 130, not 1, 2. 30 of them is in the gut, in our stomach and different digestive system, and about 100 in our brain. For example, things like gyro is in the air. You can sense your position. You are feeling how we are feeling. It's a sense. We have sense for, not speed, but for, tiredness. We have feelings, a lot of feelings These are all sins.